So we're going to start conceptual unit 7, which is exponential and logarithmic functions. So here we go. It says definition of the exponential function. It says the exponential function with base b is defined by, sorry, I'm getting a pen here, f of x equals b to the x, or y equals b to the x, where b is a positive constant other than 1, which means b has to be greater than 0, but it can't be 1, and x is any real number. Okay? So, some examples of some exponential functions. F of x equals 2 to the x, the base would be 2. 10 to the x, the base is 10. 3 to the x plus 1, the base would be 3. 1/2 to the x minus 1, the base would be 1/2. Each of these functions has a constant base and a variable exponent. By contrast, the following functions are not exponential functions. Okay, this one is not an exponential function because to be an exponential function, your base has to be a number and your exponent has to be a variable. Here they're switched. Okay, here this one is close, but remember by definition b cannot be 1, so you can't have a base of 1 or -1, or it can't be negative. Okay, remember your definition. And here you can't have a base and an exponent that are both variables, not to be an exponential function. So it says the exponential function models the average amount spent f of x in dollars at a shopping mall after x hours. What is the average amount spent to the nearest dollar after 4 hours? They're telling you x is time, and they're giving you x equals 4. So they're telling me to replace x with 4. So f of 4, in other words, the function after 4 hours, will be 42.2 times 1.56 to the 4th. And then we're going to type that in the calculator. Give me just a second. I got to get my calculator. So I have 42.2 parentheses 1.56 caret 4. And I get f of 4 is 249.9256581. And it says, what is the average amount spent to the nearest dollar? So they want me to round to the nearest dollar, which makes this $250. Okay, so after 4 hours, the average amount spent is $250. Wish I had that to spend in 4 hours. Alright, so type it in the calculator. 2 caret 1.7 is 3.24900, blah, blah, blah. And it says round to 3 decimal places, so 3.249. I'd have to use the 4th one, which does nothing to the 9. And literally, you just type in 2 caret 1.7. Alright, try this one. Come back when you're ready. You're going to type 2 caret negative 3.3. I always put my exponent in parentheses. Not necessary sometimes, but I don't mess around. Alright, and again, to round to 3 decimal places, that 5 is going to bump it up to a 2. Okay, type this one in. And you should get 6.258. Notice I just type in 2 caret, type in the square root of 7. 3 decimal places. The 2 isn't going to do anything to the 8. Okay, type this one in. Even though your exponent is pi, type it on the calculator. Pi is the second caret key. And you should get 1, 2, 3. The 3 isn't going to do anything to the 8. Alright, the function f of x equals 600.5 to the x over 80 models the amount in pounds of a particular radioactive material stored in a concrete vault, where x is the number of years since the material was put into the vault. Find the amount of radioactive material in the vault after 140 years. So again, they're telling me that time is 140. So the function after 140 years is going to be 600 times 0.5 to the 140 over 80. Now when you type this in, let's see if I did it. Yeah, I type in 600 parentheses 0.5 caret, and then I did parentheses 140 divided by 80. And it says to the nearest whole number, so 3 won't bump it up. Alright, so characteristics of exponential functions. The domain of y equals b to the x consists of all real numbers, because this function will go forever and ever and ever in both directions. The range goes from 0 to infinity. These things, unless you shift them up or down, these things won't go below 0. Now you can shift them, but they're just talking about mother function here. Those are the characteristics of mother function. Now remember, if you shift them and transform them, it's going to be different. Also, if your base is greater than 1, and remember, base can't be negative ever, but if it's bigger than 1, like 5 or 1.8 or 2.7, then you're going to have what we call an exponential growth function, which means it heads up towards the right. If your base is between 0 and 1, like 1/2 or 2/3 or 1/5, okay? I don't mean negative, I mean between 0 and 1, then you're going to have what we call exponential decay, and it comes down to the right. Okay, here's something that's interesting. The graphs of all exponential functions of this form will pass through 0, 1, and actually they will pass through 1b, okay? If b is greater than 1, then it goes up to the right. It's an increasing function. If b is between 0 and 1, it's decreasing function, decay. The function b to the x is 1 to 1, which means it passes the vertical line test and the horizontal line test. The graph of the function approaches but does not touch the x-axis. And again, that's unless you shift it up or down. So to graph an exponential function, you're going to make a table of values, choose your x's, and I said choose -2 to 2, but you could find them any way you wanted to. Find the y values, plot the ordered pairs, and make sure that your graph goes through 0, 1, and 1b. Okay, so it says graph 2 to the x. Well, if I plug in -2, I'm going to have 2 to the -2nd. Type it in, 2 caret -2, and you get 0.25. So that ordered pair is -2, 0.25. -2.25. This should be growth because my base, so I'm expecting this thing to do this. My base is bigger than 1. If I plug in -1, I have 2 to the -1st, 2 caret -1, and you get 0.5. So that ordered pair would be -1.5. It's about right there. Plug in 0, 2 to the 0, anything to the 0 degree is 1, so 0, 1. Plug in 1, 2 to the 1st is 2, so that's going to be 1, 2. Plug in 2, 2 squared is 4, so that's going to be 2, 4. And if I connect those, knowing that it's going to be an exponential growth function, there we go. Alright. Okay, this one is going to be decay because my base is between 0 and 1. So if I plug in 1/2 to the -2, and if I was typing this, I would just type 0.5 caret -2, and you get 4, so that would be -2, 4. Right there. Plug in -1, I'd have 0.5 to the -1st, and that's going to give me 2, so -1, 2. Okay, 0.5 to the 0 would be 1, 0, 1. 0.5 to the 1st would be 0.5. And 0.5 squared would be 0.25. I plot that to 0.25, and sure enough, we've got decay. Okay, pretty easy. Alright, so it says graph the exponential function by making a table of values. You can if you want, guys, but look at my base. 4 divided by 3 is 1.3 something, 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 something. So my base is bigger than 1, which means it has to be growth. This is not growth, that's decay. That's coming down, that's decay. This is coming up, but we know that it should look like this. And it should always pass through 0, 1, and 1b. Always. So there's my 0, 1, and there's my 1 and 1.3 something, something. There you go. It's got to be b. If you're just matching, you don't need to do all the math. I mean, you could. You could make your table of values and plot the points, but in a multiple choice situation, if you know it's growth and there's only one of those that looks like growth, that's got to be it. Okay, so how do you graph an exponential function? Well, you make a table of values. Then you plot ordered pairs. Make sure that they go through 0, 1, and 1b. And connect. Alright. So now we're going to do our transformations. Oh, yay. Alright, if they add or subtract on the ground, that's going to shift up or down. If they add or subtract in the air with your crazy X, remember that's going to be backwards. So if they're adding, it's going to go left, and if they're subtracting, it's going to go right. If your negative is on the front, on the ground, that's going to reflect over X. If your negative's in the air, it's going to reflect over Y. If you multiply on the ground, that's going to be a stretch if C is bigger than 1 and a shrink if it's between 0 and 1. Whereas multiplying in the air is going to be a horizontal backwards, so it's going to be a shrink if C is bigger than 1 and a stretch if C is between 0 and 1. Okay, so you are going to do what we always do. You're going to figure out who mother is, find some ordered pairs for her, plot the ordered pairs. Then you're going to do your transformations, just like we always do. If you're doing it in the air, you're doing it in Asymptote because it's with your crazy X. If it's on the ground, you're doing it to Y in PEMDAS order. Plot them, and then we're done. Alright, and then asymptotes and domain and range. The asymptotes. For mother, your horizontal asymptote's always going to be Y equals 0. So if you shift up or down, that will be your new horizontal asymptote. Okay, so if I just had Y equals 2 to the X, my horizontal asymptote would be Y equals 0. But if I did something like this and said Y equals 2 to the X plus 5, then my horizontal asymptote would be at 5, because this would shift it up 5 units. Your domain, your domain will always remain negative infinity to infinity. And the range, again, will always be 0 to infinity unless you shift it up or down. That will be your starting point of the range instead of 0. Alright, so here we go. It says, use the graph of f of x equals 3 to the x to obtain the graph of g of x equals 3 to the x plus 1. So mother would be 3 to the x. So if I do 3 to the negative second, I get 0.11111. So this would be negative 2.11 repeating. If I do 3 to the negative first, that's going to be 0.3 repeating. So this would be negative 1.3 repeating. If I do 3 to the 0, I get 1. If I do 3 to the first, I get 3. If I do 3 to the second, I get 9. So there's my mother point. So if I plot those, negative 2.1, negative 1.3, 0, 1, 1, 3, 2, 9. So there would be mother. Okay, so now to get, I need another color, to get g of x, This says subtract 1 from all the x's. So minus 1, minus 1, minus 1, minus 1, minus 1. That's going to give me negative 3.11. This is going to give me negative 2.3 repeating. Negative 110319. So if I plot those points, negative 3.1, negative 2.3, I'm a little high there, negative 110319. And notice how it just shifted it left 1. Okay, my asymptote, we did not shift up or down, so my asymptote, my horizontal asymptote is going to be y equal 0. My domain is negative infinity to infinity. And my range, again, I did not shift up or down, so that's going to be 0 to infinity. Okay. Alright, so if we do this one, now this one we're going to shift down 3. So if we do mother first, I would have 2 to the negative second, 2 to the negative first, 2 to the 0, 2 to the first, 2 squared. 2 caret negative 2 is 0.25. So negative 2.25. 2 caret negative 1 would be 0.5. So this would be negative 1.5. 2 to the 0 is 1. 2 to the first is 2. 2 to the second is 4. So if I plot those, negative 2, 0.25, negative 1.5, 0, 1, 1, 2, 2, 4. There's mother. That's y equals 2 to the x. Okay? So now this says subtract 3 from the y's. So if I subtract 3 from the y's, I get 0.25 minus 3, negative 2, negative 2.75. 0.5 minus 3 is negative 2.5. This will be 0, negative 2, 1, negative 1, 2, 1. Okay, so if I plot that, I'm going to have negative 2, negative 2.75, negative 1, negative 2.5, 0, negative 2, 1, negative 1, and 2, 1. And sure enough, this thing got shifted down 3 units. So my asymptote is now going to shift down 3 units. So my asymptote is going to be at y equals negative 3. My domain is still going to be negative infinity to infinity, but now my range, mother, goes from 0 to infinity. This one is going to go from negative 3 to infinity. Okay? Alright, so now if we look at this one, now e to the x. E is just a number, it's like 2.72. Okay, so don't panic on the e's. Alright, so when we have e to the x, sorry, let me get my right color. Okay, this would be e to the negative second, and you literally type it in. Your e is the blue above the divide, so you hit second divide, caret, negative 2, and I get 0.135. So that would be negative 2.135. If I plug in negative 1, e to the negative first, second e, caret negative 1, I get 0.368 if I round. So this would be negative 1.368. 0, e to the 0, anything to the 0 is 1, so 0, 1. E to the first would be 2.72. And e squared would be second e caret 2, 7.39. So this would be 2, 7.39. So if I graph mother, negative 2, 0.13, negative 1, 0.3, 0, 1, 1, 2.7-ish, 2, 1, 2, 3, 4, 5, 6, 7, and a little bit. There's e to the x. Okay? So now we got all kinds of crap going on here. Let's do the stuff on the ground first. That's to y. They want me to multiply by negative 2 and subtract 1. We've got to do it in PEMDAS order. So I'm going to multiply my y's by negative 2. So I have 0.135 times negative 2. Negative 2, negative 0.27. 0.368 times negative 2. I get negative 1 and negative 0.736. This is going to be 0, negative 2. This is going to be 1, 2.72 times negative 2, negative 5.44. And this is going to be 2, 7.39 times negative 2 is negative 14.78. That's done. So now we need to minus 1, minus 1, minus 1, minus 1, minus 1, minus 1. That's going to give me negative 0.27 minus 1. So that's going to be negative 2, negative 1.27. That's going to be negative 1, negative 1.736, 0, negative 3, 1, negative 6.44, 2, negative 15.78. Alright, so then we have, they are multiplying, they're saying multiply my x by 1/3. So if I do the opposite of that, I'm going to multiply by the reciprocal, which means I would multiply by 3 over 1, which is multiply by 3. So times 3 times 3 times 3 times 3. And I get negative 6, negative 1.27, negative 3, negative 1.736, 0, negative 3. 3, negative 6.44, and 6, negative 15.78. Okay, so if we plot these now, negative 6, 1, 2, 3, 4, 5, 6, negative 1.27, negative 3, negative 1.736, 0, negative 3, 3, negative 1, 2, 3, 4, 5, 6.44, and 6, I can't go down to negative 15, so we'll just graph these. And notice how it turned it upside down because of the negative. It stretched it by 2, which made it more steep. It moved it down 1, and it horizontally stretched it by 3. So it went wide this way. Alright, my asymptote, since it moved down 1, my asymptote is going to be y equal negative 1. My domain is always going to be negative infinity to infinity. And my range now goes from negative infinity up to negative 1. Okay? Alright, so it says use the graph of f of x equals 4 to the x to obtain the graph of g of x equals 4 to the x plus 3 plus 2. Okay, so hit pause, come back when you're ready. And hopefully you got C. Alright, again, if you're just trying to match graphs, I just kind of think of, okay, mother would have to go through 0, 1, I'll do it down here, 0, 1, and 1, 4. That would be mother. Mother would be 4 to the x. This says I have to go 3 left. So if I take this point and go 1, 2, 3 left. And this point, 1, 2, 3 left. That would put me right here. And then this says I have to move 2 up. So So if I take this point and I move 2 up, and I take this point and I move 2 up, and I redraw it, it's got to be C. Alright. Go. You do this one. Hit pause. Come back when you're ready. And hopefully you got 1. All this is going to do, this negative, is it's going to flip it upside down. Mother would be 0, 1, and 1, 2. If I turn that upside down, this comes down here, this comes down here, and there you go. Okay. Go. Hit pause. Come back when you're ready. And hopefully you got D. Again, e to the x would pass through 0, 1, and 1e, which is 2.72. So 0, 1, 1, 2, and a little bit. There would be mother e. Okay, and this says I'm going to go 3 units left. 1, 2, 3. 1, 2, 3. There we go. Okay. Do this one. Hopefully you got C. E to the x again would be 0, 1, 1, 2.72. There would be mother. This says I'm going to move down 1. So down 1, down 1. And then this says I'm going to stretch it by a factor of 2 horizontally, which means it gets wider this way. So it's got to be this one. This one would be like if you were multiplying by 2. Or something. This would make it thinner. This is going to stretch it horizontally. Okay? Alright, so how do you transform graphs of exponential functions? Well, when you do your y stuff, you do them in PEMDAS order. And you do your x transformations in Asymptote order. Alright. So we are at homework, which means we are done. So happy homeworking, and I will see you next time.